All right, 10-1, rational exponents. All it is manipulating square roots, cubic roots, and then you deal with negatives. So here we go. Again, if you haven't seen the pre-lesson, I would highly encourage you to do so. You're going to miss out on a whole bunch of assumptions going into this. So here we go. 16 to the 1/2 power is the same thing as the square root of 16 to the first power. So the denominator goes in the index. The numerator is the power of the base, which is just the same thing as the square root of 16, which is just 4. Again, you only need to put the principal root, which is the positive one. Now this negative exponent, you can do that first, or you can do it last. I like to do it last, but there's a danger that you might forget. So one student is just going to look at it like this and say, hey, that's the same thing as this. So this equals 4, but then there's a negative exponent still there, so we got to put it where it ain't. Or the next student would take this whole thing and put it where it ain't right away. And 16 to the 1/2 power is just the square root of 16, so that would be just 1/4. So either way is fine. Don't panic when you see the decimal there in the exponent, because that's just a different way of writing. 16.5 is the same thing as 1/2. In other words, you don't want a decimal there. You want to turn it into a fraction, and then it will make sense, because this is the same thing as the square root of 16 with a little invisible 2 there and invisible 1 there, which is just 4. A little bit of a different twist here. Again, if you listened to the pre-lesson, I told you to do this first. So it's the 4th root of 16. We'll deal with that cubed later. You don't want to deal with it first, because you're going to get a massive number. So this is not the square root of 16, it's the 4th root of 16. So what number times itself 4 times is 16? 2. Because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. But then we got to cube that, and that's 8. So my final answer is 8. Same thing. We're going to do this first. So it's the square root of 16 first, which is 4. Then we're going to cube that, which is 64. All right, again, negative. What do you want to do? Do you want to do it first or last? I choose to do it last. But 16 to the 3/2 power, we just did it. It's 64. So this turns into 64, but then one little step we haven't taken care of is the negative exponent. So that will just put it where it ain't. 1/64. Like I said earlier, you don't want decimals. So what is 1.5? 1.5 is the same thing as 1.5. which is the same thing as 3/2, and this is what we want. So it's 9 to the 3/2 power. Again, do the denominator first, which means take the square root of 9, which is 3. 3 cubed is 27. On this one, whenever there's a fraction, I like to do this first, because what that means, if I put that where it ain't and put that where it ain't, all that means is flip it. 9/4 to the 0.5 power. But we don't deal with decimals. We're going to turn 0.5 into what it is as a fraction. That's 1/2. So that's the same thing as the square root of 9/4. The square root of 9 is 3. Square root of 4 is 2. Done. All right, notice, and I did talk about this in the pre-lesson, but we have a negative inside parentheses. So that means this does apply itself to that negative. So this is the same thing as the cubic root of -8. Now remember your lesson on cubic roots. You can have cubic root of negatives. It's not a problem. So the cubic root of -8 is -2. And then we have that to the 5th power, which I'm just going to show my work. -2, -2, -2, -2, -2. That's 4. That's 4. So 4 times 4 times negative 2. 16 times negative 2 is negative 32. But we do have a little negative exponent right there. Remember, these two negatives do not cancel like your typical negatives. That just means negative 32 to the negative 1 power, which means put this where it ain't. So it's 1 over negative 32. Done. Look at the difference. The difference is, on the previous problem, this negative was inside the parentheses. This one is very sneaky. Because there's no parentheses, you need to think of this as a subtraction. And then you're going to concentrate on this with a negative in front of it. Now, when would that be really significant? If that was a square root. Because it's a cubic root of negatives are okay. Square root of negatives are not okay. So that's where it makes a huge difference. But technically, this is what's going on. So what is the cubic root of 8? Well, let me show my work. That's 2. And then I'm going to go 2 to the 5th. Remember, we just did negative 2 to the 5th is 32. So this has to be 32. And now we have a little negative exponent in there that we haven't dealt with yet. So it's 1 over 32. But there's a negative in front. So we're just going to slide it right in there and we're done. A lot of little steps there. Again, this is not included in parentheses. So you have to think of it like this. And this just says, figure out what the cubic root of 27 is. Well, the cubic root of 27 is 3. Does that negative put it where it ain't? No. It's just a negative that comes along, so my answer is negative 3. All right, now we have a power to a power situation. If you remember the rule, this is when we multiply powers. So that's like 3 over 1. So 3 over 1 times 1 over 2 is 3 halves. And then we're just going to take the square root of 9 first, which is 3. And then we're going to cube it, which 3 times 3 times 3 is 27. Again, you can go power to a power, but I'm going to show you something else. I'll just write this down twice. And this is where math gets a little interesting. What do you do first? Well, student number 1 comes along, concentrates on just that. That's the square root of 16, which is 4. But now we have that to the 1/2 power, which is just the square root of 4, which is just 2. Now, what if a student looks at this and says, well, in the last problem, you said power to a power, so let's stick with that. So that would give us 16 to the 1/4 power, which is the same thing as saying find the 4th root of 16. Guess what that is? 2. So, does it matter which way you go? Nope. All right, now these two problems, really, they're identical. But notice, on this one, there is a square root of 16, so that's why we might go that way first. There is no perfect 4th root of 4, so we're going to be stuck multiplying these together. So we get 4 to the negative 1, which is 1/4. Just put it where it ain't. And we're going to do the same thing right here. 4 to the negative 1 power. What's that? 1/4. Now this last one is what I refer to as the PEMDAS special. And if you guys have heard me on multiple occasions, I've told you that if you have a problem like this, it's okay to go power to power, power to power. We did it here, etc., etc. And here you can do it too. 2 times 3 is 6, 3 times 3 is 9, and that's okay. But whenever there's a plus, you may not distribute that power to these and multiply. You just can't. I've shown you in multiple ways. So if we just honor PEMDAS and go parentheses first and only look at what's in the parentheses, 4 to the 1/2 power is the square root of 4. plus the square root of 9, which is just 2 plus 3, which is just 5. See, now we've taken care of everything inside the parentheses. Now we go to that exponent, and we get 25. See, if you actually distributed that to that and that to that, you'd get 4 to the 1 plus 9 to the 1, which is 13. Not right. There you go, you guys.